Hello everyone, my name is Stefan Monteiro and I am delighted to be here today to lead the study Perform Analysis on Deepfake Detection Challenge Dataset. Here is the agenda for this talk. It will be organized into 5 chapters: Introduction, Contextualization, Methodology, Results, and Conclusions. Now we will get into detail about each chapter. Introduction. What are deepfakes? Deepfakes are a type of audiovisual content manipulation that employs artificial intelligence to generate fictitious information, typically photos or videos, in which a person appears to say or do something they have never said or done. This modern technology enables you to generate very lifelike photos and videos, making it more impossible to tell what is genuine and what is not. This technology poses serious problems with ethics, security, and confidence in the information we consume. So deepfakes pose several risks. The following are the 6 most commonly discussed in the community. Manipulation. Deepfakes may be used to sway public opinion and impact political, social, and economic decisions. Cases like these are very typical during national elections. Fake news. They can distribute incorrect information and distort the truth, weakening confidence in social media, the spread of bogus news. Lie. Deepfakes may lead people to believe in never occurring events or remarks. One case is the royal family case recently. Integrity. Deepfakes jeopardize the integrity of information, making it increasingly impossible to distinguish between the genuine and fake. Trust. The emergence of deepfakes might erode confidence in information sources and individuals who presented in altered material. Social communication eventually loses credibility. Security. Deepfakes can jeopardize personal and financial security, posing a national global security danger. An example, a person may mimic the account manager to persuade the individual to approve a banking transaction. Contextualization. Now, let's look at how deepfakes are created. Now we know what are deepfakes, it is important to know how they are created. Deepfakes are created using the GAN, Generative Adversarial Network algorithm. GAN has 2 major components, a generator and a discriminator. The generator manages the synthesis of synthetic data, such as films and photographs, from a collection of input data. The discriminator decides if the generated data is true or false. These 2 components interact in a constant feedback loop, training one or the other. The generator attempts to provide increasingly realistic data in order to trick the discriminator. As a result, the discriminator is trained to discern between true and fraudulent data, pushing the generator to improve even more. After researching similar work, we choose 3 detection methods that we consider it most relevant to the analysis. The 3 algorithms are exception, ResNet, and VGG16. In this comparison table, we have 2 critical factors for this study. It's the design and suitability. The exception architecture enables the identification of complicated characteristics related model weight. That is, the algorithm can more readily avoid overfitting, which occurs when an algorithm performs well in testing but subsequently compromises in real-world situations. ResNet enables the training of deep neural networks, which allows for the quick and automated learning of subtle characteristics in data. The VGG16 is notable for its simplicity and success in a variety of computer vision tasks. Regarding suitability, all algorithms are specialized in visual computing tasks, and the exception was essentially built for detection deepfakes. Methodology. Let's now discuss data processing. The dataset utilized was the DFDC dataset, the Deepfake Detection Challenge, created by Facebook and other firms, which is highly renowned in the deepfake detection industry. This dataset underwent a split, resulting in 3 unique subsets for training, validation, and assessment, as we can see in the presentation. The training set for the detection models included around 35,000 photos. The validation set consisted of around 7,500 photos, and the evaluation set also includes 7,500 photos that use to access the performance of the models after training. The algorithm were first trained on the various data collections. The models were then training using the DFDC dataset, which included the previously described data. During the training, they were shown a wide range of deepfakes and actual footage, which helped them learn to discriminate between the two. Throughout training, performance was constantly assessed by modifying hyperparameters as needed to enhance accuracy and recall of the three algorithms. Following training, the algorithms were applied to an evaluation dataset. These findings were saved in an Excel file for further examination. To do the same study, 5 assessment criteria were used: accuracy, precision, recall, F1 score, and response time. Let's talk now about the results. And here we have a table with all the results, with the average result of each individual algorithm. And with an astounding 87.5% accuracy, exception is the most accurate model in the dataset, providing that it can accurately classify a significant percentage of the videos, of the photos in this case. VGG is next, performing exceptionally well in the video classifications with an accuracy of 83.7%. ResNet, with an accuracy of 68.7%, is not as good as the other two models. Moving to precision, Exception exhibits the highest score of 87.7%, signifying its proficiency in accurate classifications and minimal false positives. VGG continues to perform well as well, with a precision score of 84.6%, offering a balanced approach to precision and recall. With a precision of 69.8%, ResNet lags in precision, suggesting a relatively higher rate of false positives. Regarding recall, exception with 89.5% indicates its proficiency in identifying a significant portion of actual deepfakes content. VGG closely follows with a recall of 89.4%, highlighting its efficiency in capturing a substantial portion of deepfake images. ResNet with a recall of 72.3% demonstrates effectiveness in recognizing genuine and deepfake content, but it lags behind exception and VGG. With a well-balanced trade-off between recall and accuracy, exception has the highest F1 score, 88.6%, putting it first. Additionally, VGG has a high F1 score of 86.9, demonstrating its ability to distinguish between real and deepfake image with equal accuracy. ResNet shows possibilities for more optimization, especially in terms of accuracy, with an F1 score of 71%. Now, the exception and ResNet were very similar, the values were very close to each other, but in terms of execution time, the exception was clearly faster than the other two. It is processed approximately 100 milliseconds faster than the ResNet and 1000 milliseconds faster than the VGG, which is in real case scenarios might be critical. Now we'll talk about the conclusion. We have the detailed analysis on deepfake. We have made the detailed analysis on deepfake detection algorithms. We have highlighted the exception performance, not discarding the other two, but the exception was a lot better than the others. And we have acknowledging the detection algorithm for real-time scenarios. In this case, again, exception with the response time that he gave us. As future work, we would like to implement a real-time application for deepfake detection in order to allow people to detect any kind of image they have in their post to check whether they are true, whether they are false, and help the world and the social communication to retain their trust. That's all. Thank you. See you next time.